Okay, so for today, I'm going to continue with the Python basics. We're going to talk about user input and while loops, how you can write a while loop, and also when you can stop the while loop or when you can skip the while loop. Name functions. So hopefully we'll be able to finish all the basics by Friday. If not, we probably use sometime next Monday to finish basics. Then we can start doing some geospatial stuff. And so before we get started, I would like to let you know I've changed my website for the package. So it used to be geohey.xyz, right? And I have changed it back to the other one, geohey.gshub.org. It's the same, but on GitHub it's the same. You don't really notice, but you redirect that to my gs.hub website because I don't plan to renew this one next year. So going forward, so I have, yeah, it's like 12, 13. I don't want to renew, but I have this website that I pay for a couple years. So gshub.org, so I can have subdomain. So it's going to be with me for my lifetime. So I only pay this one, but I can have subdomain like gshub.org at the beginning something. So in that way, I don't need to change it. Just so you know, right now, it still works because it's going to redirect this one to my gshub.org website. So it will last forever. When people watch the video, they can get the same URL. Just want to let you know, I don't want to pay $12 next year. And all right, so today we're going to cover here. So the Python basics, we have 4 more to go. So hopefully today we can cover number 7 and a little bit number 8. On Friday, we're going to cover 9 and 10. And that's pretty much. So we don't get into details about all the basics. And if you have any questions, just ask ChatGPT. There's nothing unique or nothing special about this. These are all pretty basic. So if you spend a couple hours, you should be pretty good at it, but make sure you practice. So for today, we're going to use this one here. And you might notice here, I commented out all the stuff. Reason for that is when it's building the website, it's going to run all the source code. There, if you waiting for input, it's going to get stuck. So that's why I commented out all of them. But for the lecture, I'm going to go through that so that you understand some of those basics. See here, yeah. And while loops is also a very commonly used one for doing looping in Python. So the differences between for loops and while loops is for loops, you already know what to loop through, okay? Because you only have for something in something, right? You already know how many items in the list. While loop, on the other hand, is you don't know how many loops you're going to loop through. You don't know how many items, but you know when it's going to be stop the criteria, when there's a criteria to stop that one. So basically, there's unknown number of loops. For loop is like there's a definite number of loops, right? So similar here is right now, for example, I can have a dictionary, and then say polling activity to true while true, right? So if you while true, that means it's true. It's going to run through the stuff, and you write your name, and then ask you blah blah blah, and whether you want to continue or not. If you don't want to continue, then you can stop. Just like when you play some games using the browser, and they ask you, okay, finish this one, and then you want to continue? Yes, and then continue. If you answer that no, and then you want to stop, right? So this is the most simple one. Or it can be checking your input, and then, for example, or enter numbers. I'm going to calculate the sum, and then I'm going to ask you, do you want to continue? Yes, then you do it again. Otherwise, you're going to stop. Make sense? So there are tons of like real applications. And maybe let me show you here. I'm just going to show you, like, for example, simple application. You're going to design an application that allow the user to enter numbers, and you want to calculate the sum of all the numbers being entered until the user say done. Then you're going to print out the sum. Otherwise, you're going to keep continue. Make sense? So how do we going to design this one here? So think about it for a second. How do you design this program that allow the user to enter all the time? So can you use the for loop? No. Why? Yeah. Yeah, you need to either divide it. This here you don't have, right? I can enter 5 numbers, I can enter 10 numbers, you have no idea. So here, this is where the while loop they play a role, right? So think about here, what kind of components, how do we calculate the sum? So what do you need? So I'm going to allow the user to enter numbers, and if they enter, say done, and then I'm going to print out the sum. If it is a no, and then continue. Do you want to continue? Or do you keep entering the number? Yeah, not dictionary. I think here it would be a list. So for example, I can say values equal to, right? We can have an empty list in here. So when the user, you can, so the input, we're going to use this so-called input function. So the input function allows the user to enter something. So it will be like this. Then I can just simply say while true, okay? While true means it's going to be, it's just true. They're going to run all the time. It's going to go again and again. Wow. Oh, this is amazing. I don't even need to write. Guess what I'm going to do? Yeah, sometimes it's annoying, yeah. So if you want to really practice for doing the lab, you turn it off. So it's better for you to learn. But once you're good enough, you can understand the code. It's perfectly fine to use. Right? You say enter value. If value equal to put in a quick, then you're going to break. Otherwise, you're going to append the list into that. And you're going to continue to run all the time. So after that, after it's finished, how do we calculate the sum? Print, you can do it like this, and then parentheses, F, okay, say sum, perfect. It's smart. Right, makes sense? It's only a couple lines. So what is this one is doing here? We're gonna give an empty list, and we're gonna print out, say while true, because you don't know the number of items. So you need to have this one here, and you're gonna enter a value. You just enter whatever value you like, and if they enter quick, it's going to break. Otherwise, you're going to append a value. Let's see if this one works or not. I think it's not going to work, but we can give it a try. See why it's not working. So I'm going to execute this one, and you're gonna, you see here, enter a value, and say 1, 2, 3. Okay, it's not doing anything. I never type quick. Enter. What do you think? Going to throw errors? Probably. Yeah, unsupported operand plus in and str. Why? So because when you use the input function, everything is treating as a string. Okay, so it's not a number. So in order to be able to actually put them, to add them together, you need to either doing here convert this number to convert this input string to a number, or you can do something here. So I think the easy way would be something like this: float, and then value. So what it's doing is you allow the user to enter. So the user enter whatever is being treated as a string. So it's not a number. You convert that number to the string to a floating number, and then add that to the list. Then you have the list. Then you can print it out. So in this case, I can do it like this. I can say 1, 2, 3, 4. Okay, and then quit. Hit enter. What? Oh. Let me print out the list. Something is wrong here. Print values. On this one. Oh, I need to restart because the list value is executed. Let me do it again. 1, 2, 3. What? Okay, 1, 2, 3. Then quit. Okay, now it works. 2, 3, the sum 6. Make sense? So you can allow it to break. How about this? I can say if the user, for example, enter anything other than numbers, how do you do that? We haven't covered this yet, but eventually your program needs to be robust enough that can handle everything. Right now it cannot, right? So if I All right, run this one again. Go here. I can do like 1, 2, and then okay. Going to run into error because what it's doing is going to check this one here, and then it's not equal to input. It's going to append this one, and then eventually going to sum together. It doesn't work because you cannot work. So what you need to do here is to try to convert this one to a float number, and if this doesn't work, you skip it. Make sense? So this one is probably going to the last one. Chapter number 10. It's called exception. So how we handle the exception. But it's pretty easy here. Just add one more line. It's called try. So in Python, it's called try except. So anytime if something you suspect that it might go wrong, then you put in within the try except code block. So for me here would be except, and just say try except. Something goes wrong, you say invalid value, and then you're gonna skip, and then gonna go to the next one. Okay. So in this case, this program right now is bulletproof. So we never go wrong because you know how to handle it, right? So right now I can do 1, 2, 3, and blah 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 blah. Okay, I can do another one. You say invalid values. It's going to ignore it, right? And if I do 5, 6, okay, and then quit. Make sense? So your program need to be able to handle all kind of exceptions. Of course, right now we haven't covered it, but when you build your package and you want to just people to use your package, you need to be able to handle all kind of exceptions, because when you're doing the testing, you know what to provide, and then your program looks perfect. But when other people are using it, they have all kind of problems. Then you actually need to expect the problem, because otherwise, sometimes there are a lot of bugs. That, for example, like Google released the what's they call the Gemini AI for generating photos. I'm not sure if you follow the news, and then have all kind of issues. So now they have to pause it, fix the bugs, and then try to do it again, because there are some bugs that you cannot capture. So when it released to the public, people are going to try it out, and people are going to enter things that you may not expect. They're going to enter all kind of stuff. So sometimes it can cause a lot of issues. Anyway, so this is the most simple way if you're doing the while loop, is that you don't know anything, and then so you can here you can do the break, or you can break means you stop the loop, and then it's going to be exit the loop. Otherwise, it's going to be continue. So I can also do it the other way. I can, if the user enter anything invalid, doesn't start with a number, then you can so-called continue. You can also do it here, like pre invalid values. Although this one here is not really necessary. Continue means that you skip whatever you're going to do. So let me show you like what this one is doing, right? I can show you that just to give you a little bit more information, like why this is, for example, value added, and here you're going to say invalid value, and then it's going to continue. I can have another one here. Maybe let me put this one here, just to show you the differences, what this one is doing. So pay attention to this program here. While true, right? It's going to allow you to enter the value. If you enter quick, it's going to break, and all this will not be executed again. It's going to be done. Otherwise, it's going to try to convert that one to a float number. If this is the correct number, it's going to come here, finish this one. It's not going to execute this except, okay? If something is right, then it's going to come here. It's going to show you the value added. If you enter something incorrect, it's going to say invalid values, and then it's going to continue. Continue means this line, anything after is not executed. So you're going to come back to this again. Make sense? So continue means you skip anything beneath. You go back to the loop. Break means you stop the loop. You exit the loop. So we're going to be come to here. So now if I execute this one, for example, let me need to type quick. Let me re-enter this one. So empty. And so pay attention, right? So right now, if I enter 1, see what's going to print it out. You're going to say value added 1, okay? 3, okay? and if I enter something not number, are you going to see the value edit? Just say invalid value. So this line here is not executed. The reason for that is because if something goes wrong, it's going to execute this code block. It says invalid value, and it's going to say continue. Continue means it's going to skip anything beneath and then go back to the loop. Okay, so this is where the break and continue means. If you type, for example, quit, that means it's going to break. Break means there's no loop again. The loop is finished. That's why it looks like this. So keep in mind, break and continue. Those are the two keywords to break the loop. Otherwise, if you have something like this and then you keep going on, it will crash your computer because it's a definite loop. There's no stopping condition. So in here, right, if I, for example, if you accidentally forget to put this break keywords in here, you'll be in trouble. Know why? Or you can say, okay, and instead of like quitting, how about this? Right? Without this break keywords, and see this one? Oh, this is pretty intelligent. Now it says this one kind of gray out. That means it never reach here. That means your program can never reach this one. It's always going to stuck in the loop because there's no stop condition. You need to, if something like while true, that means it's going to run forever. So you must have a stop break something within the loop, otherwise it's running forever. So again, I can try to run this one just to show you what is happening. I might need to force reboot my computer. Maybe not, but I can stop probably Visual Studio Code. But here, right? See, 1, 2, 3, blah blah, and then quit. See? It's never stop. Because there's no stop condition, there's no break within here. Luckily, there's a button here, interrupt, or maybe restart. Okay. It doesn't allow me. Oh, it's stop. Okay, it's good. Otherwise, just like on Windows old days, like Windows XP, it's something popping up like click, 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 and boom, 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 boom. This is the program that's bad because you don't have a stop. So make sure if you have while true, then you have a stop condition. Or I can do it something like this, a better way, right? If you enter any number greater than 10, I'm going to stop it. So this is where you can actually, right? So I can say I equal to 1, okay? I can do it like this while, okay. I don't know how it read my mind, like less than 10. And I equals to 1, I less than 10. So pay attention to this one here. Right now, I'm not using the true condition, but I'm using I less or equal than 10. So what this one is doing is here, first time I equal to 1, right? And I can have a printing out here, print okay, values, whatever. So I equals to 1, and is I less than 10, less or equal than 10? Yes? And it's going to say values added 1 to the power of 3. So basically 1 to the power of 3, 1, right? And then it's going to say I has equal 1. Basically, I equal, this is the same as I equal to I plus 1. It's basically the shortcut. So now y is, I becomes what? 2, right? Is 2 less than 10? Yes? Then it's going to be like 2 to the whatever. So it's going to become 2, 3, 4, 5, 6, 7, 8, 9. And then when it becomes 9, I is 9, then it becomes 10. In coming back, okay, it's still 10. And when it's 10, it's coming back, oh, you're going to see 11, then it stops. Make sense? Let me make it a smaller one so we can do the debugging. So just show you, this is super important. So sometimes you don't need to have a break condition. You can use this one as the condition. So if it doesn't meet the condition, it's going to break. But if you have while true, then you must have a stop break something inside your loop. Otherwise, you're going to have trouble. So let's run this one, and then I can do the debugging just to show you here. Maybe we have a breakpoint here, okay? And then I'm going to debug this cell just to see how it actually loops through the content. And so, right? So the first time here, I equal to 1, and I less or equal than 1. So pay attention to how it's going to run through inside, right? Then you're going to value going to add 1 to the power of 3, and I equal plus 1. So right now it's 1, is going to become 2. See? Now it's 2. And you see it's coming back again. So the loop is coming back again. If you want this one again, you add it. Now I becomes 3. Right? Is 3 less or equal than 3? Yes? Yes? And then I becomes 4. So pay attention, right now it's still 3. So if I run this one again, see how it's going. And you're still going to check this condition, 4 less or equal than 3? No. Then going to skip and then come to here. So then it's going to exit the loop. Right? So 1, 8, 7. So this is super important. So make sure you understand the logic, right? While something, so there's a condition. If there's a condition, if the condition is become false, then you exit the loop. So this is where, depends on what you want to do, you can have break, or you can have continue, or you can have something. So similarly, right, I can also do this one here and say while true. Can I do this? Right? So how do you get a break? So you need to have something like this. You can, if I greater or equal than 3, colon, break. Okay. This program is the same as the one, rather than you have the break section at the beginning. Same thing. So this one here, right? So right now, if I run it, run through that, oops, there is no. Oh, you need to run this one. Oh, it's different, right? Y equal than 3 because 2. So this one you need to be like y equal than 4. So same that we earlier. Now, understand? And other than that, you can skip, you can continue. So continue means you skip it, it go out the loop without executing it. Yes? No. So exception has doesn't really have anything to do with the condition. So the condition is whether it's true or false. It must be true or false. Why except is to capture like it might have an exception. If something might go wrong. So it's different applications. Okay. Any other questions? So this is a pretty simple one, but inside there you can make it very complicated. But this is essentially how the while loop is doing. And you can use continue, you can use open. Yeah, we already covered all of those. So hopefully now it makes sense to you. When do you use the for loop? When do you use the while loop? You use the while loop. If the condition is not a condition, it's just like true, then you need to have something to break out of the loop. Otherwise, you're gonna have trouble. Luckily nowadays, Visual Studio Code is pretty intelligent. It tells you when, if the line is grayed out, that means the line never reached. You have something. And yeah, for other stuff, you can just go through that. It's not very complicated. So when you go to the next one, functions. And I would say this one is probably the most important building block that you need to have for your package. So most likely your thing is going to be functions or classes. Classes is a little bit more advanced. A function is going to be everywhere. So we are calling the function, for example, print sum, minimum, maximum. So those are the functions that you can call, and then you can provide something, and then you can get the result. So function is allow you to reuse your code block without having to repeat everything. Okay, so you can define something, greet the user, and then you can print out something. So here, right, just a simple function. So the function is being defined as def, and then the name of the function, and then parentheses, colon. Inside there, you can do something. So when you want to call the function, you'll be something like this. You call the same name of the function, provide the parentheses. So in this case, I define a simple function, and so the 3 double quotes, this is called doc string. So basically it's documentation. I will show you how to build the documentation. For now, this is just simply just to explain what it's doing, but you don't necessarily have to have something like this. You can also do just a simple hashtag, okay? That's basically a command name, but when you have good documentation, you want to have this one. It's better. I will show you a better way to how to do it later. But for now, assume, okay, this is something like the function. Define a function and then have something to do within the function. So everything needs to be indented within the function. And when you try to call a function, you just write the same name, like this. So it's super easy to do. But this one doesn't have any parameters, right? It's a hard-coded function. You cannot customize because it doesn't have any parameters allow you to provide, right? So later, for example, you can provide a function that and then calculate the sum. It doesn't matter what you provide to me. You give me a list, I give you a sum. You give me a list, I give you a minimum of average, whatever, right? Same idea in here. So you can allow the user to provide something. So this is called a parameter or argument that allows the user to provide, right? So if you provide username and it's going to say hello, blah, 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 right? So if you here call this function and you provide this parameter, you're going to use that as something inside there, right? So in this way, the function will give the result based on what provide. And the number of parameters can be unlimited. So in this function here, right, I have 1 and 2. So animal type and the pet name, I have something and then the name is blah, blah, right? So you can say here, okay, I have a hamster. The name is Harry, for example, right? That allows you to provide parameters. So you're going to inside there, you can have multiple parameters, and you can also do the parameter name. So you can call it multiple times. So think about here, you can do it multiple times. You don't need to rewrite the function again. It's going to call this function, and it's going to based on the sequence, based on the order of the parameter. So first one is going to use this. Second one is going to be this. So this, you can think about these names here are the placeholder for you to use within a function. So the name here doesn't really matter. It can be any name. So this name here, oops, what is happening? So the name here can change to anything you like. I can see here, right click, and I can change this one, for example, rename symbols, right? Rename it to something else. So I can say, just say animal, okay? A-N-I-M-A-L, right? Hit enter, take a look. It's gonna change all to animals, so it doesn't matter. So similarly, I can change this one, right? Pet name, right click, rename symbol, change to pet, gonna change. So even though I change the name, you see, doesn't matter. The result still can print it out. So these two here, the name can be anything as long as it's a valid Python variable name, right? If you don't provide it. So right now I'm just providing the value. I don't write out this specific this name. So you can just do it like this. But sometimes you might want to change the order, right? So if you do it like this, if you reverse the order, it's going to cause trouble. So you can either, when you are calling a function, you can have a so-called keyword argument. So if you do it like this, then you don't need to pay attention to the order. You can, for example, this function, right, has these two parameters. You can provide the first one, and for example, the name of the parameter, and then you give a value, the name of the parameter, you give a value. But you can also reverse the order. You can do it the other way. You can have the pet name first and then the animal types later. It doesn't matter. So it's up to you. There's no right or wrong answer. It depends on what's your preference. If you want the user to, if you don't provide the parameter name, then it's going to based on the sequence, based on the order. But also keep in mind, if you provide the first one, everything after need to provide the parameter. So here, pay attention to this one, right? If I run this one, it works fine. But if you do it like this, then it's not fine. See like this? I provided animal type name and then the pet name. If I don't do it like this, you cannot do it. When you stop providing this parameter name, everything after, you need to provide it as well. See here? No, it's the position argument follows keyword arguments. So if you already provide, you need to do it. Or you don't provide at all. Okay? Then this is fine. It's going to use the order, right? So this is the first one, this is the second one by default. But you can also provide the second one. You can do this one, pet, and then do this, equal. This one is fine. So you can have the default and then have the position argument, but you cannot have the position first and then default because it messed up the order. Make sense? So usually for me, it would be like this. I mean, the recommended way would be just like if you only have 1 or 2 parameters, you don't need to write down the name. But sometimes the function might have like 5 or 6. You only want to provide the first one and also the last one. Then you provide the first one and then the last one using the position, rather than have to write everything out. So this is like different ways of doing that. Also, you can provide a default parameters, like define a name and an animal type equal to something. That means, okay, this function has a default parameters, so that if the user don't provide, it's going to use this default name. Okay, something like this. I have a dog. My name is Will, and I didn't provide it its dog, right? I only provide its pet name equal to this one, and by default, I'm going to use this animal type. But you can change it, so you can do it like provide a hamster like that. And similarly, you can provide function like, okay, tell me your name, what's your major, or something like that, right? Similarly, for example, describe, write a simple one here. def, okay, I'm going to define a new function. I'm going to say describe, okay, student, and you can provide name, okay, and then say measure, okay. By default, I'm going to say this. I'm going to say your measure is JS, okay. Within there, I can print out, okay, print. Okay, cool. See here, I just have a simple function, and then tell me your name, and then I can call, okay, def, okay. No, not def again. Right now, just we just describe, okay. Jessica. What's going to print out? It's going to say Jessica is measuring. Yes. Okay. I didn't provide it, but I can do it like this. I can say biology. The provide biology is going to say, okay, measuring biology. Right. So this is how you call the function. But you can also reverse the order. I can also just write measure, example. It's the same result. I can also provide this one, name equal to. Okay. This is fine as well. You can provide all the arguments. You can also switch the order. Okay. I can do it like this. Comma. Call the function. Enter. Be the same. But you cannot do it this, okay? If you provide the first one, already have the argument here, the position, then everything after need to provide that. Make sense? So make sure that usually the recommended way will be like this. You only one or two, you don't have to, you just have this. But of course, this is like unexpected, so you need to make sure you follow the order of the function. And the number of arguments can be like a lot. So one example will be here, right? I can show you how pretty much all the leaf map, for example, every is pretty much all the functions. So if you go to the API reference and go to any module you like, and if you look at the documentation, pretty much everything is just a function. So for example, you can go to bbox to GTF, for example, a bounding box to a geodata frame, right? So you see here, bbox, and then have something equal to something, right? So this one is the required parameters. This one is optional. So anything you have an equal sign there, that means if the user don't provide, it's going to use the default parameters. And you can click to see what's inside, right? Here shows you, for example. Oops, where is it going? Here, take a look at the source code, right? It's just a df and then a function, and then you provide something, and then blah blah, and then so here, right? Just one or couple simple lines, for example, blend 2 images. You provide the first image, the second image, and then you can have a bunch of other optional parameters. The other one here is the KWARGS, so keyword arguments. This one means unlimited. You you can provide as many arguments as you want. So this is kind of like the while loop, right? The while loop, you don't know how many times you're going to loop. This one is the same. You don't know what user might use other keyword arguments. But this can be used in calling other functions. So here, for user, they need to provide this too. Everything else is just optional. But you can look at the source code, how this is being utilized. This one is a lot more complicated, but it's still just a function. And within there, you can have all kind of stuff to do something. And then even at the end, you might need to return something. So most of the function will return something. Return means you get the result back. Otherwise, you will just print it out something. Then you don't really do anything. So next, let me show you like real world examples, right? You give me a list, I can calculate your sum, right? So how about this? I'm going to define a function called df, and it's a little bit like, this is a simple one, it's unnecessary, but I'm going to say it's a calc, or maybe summation, okay? Yeah, some no, it's too simple. So how about define a function called total, okay? So within there, you need to provide me number or list or anything. So I allow you, for example, I'm going to say values, okay? And say I would say sum, maybe call. Yeah, I cannot use the total again. So you'll be change the name. Sum values, okay? I'm going to have this function, and it's in there. I'm going to say total equal to sum values. This looks like a stupid program, but I just want to show you why I'm doing this. And then I can say return total. This is a simple one, right? So if you give me a list of values, I'm going to use the sum to hold the list, and I'm going to return the total. And this one, right? So now I can sum values, right? Provide list 1, 2, 3. I'm going to return the values. So right now I'm not printing out the result. I'm just saying return. Return means you can assign this one to a value. So now I can, for example, I can call this one, say a equal to sum a, b, c, d, blah, blah, blah. And then if you print out a, you get 6, right? If you change it, for example, I can say 22. Run this one, a is going to become 26. So basically return. So most of the functions most likely have to return something. Otherwise, if you don't return, pay attention to this one, right? If I run this function and you assign to this one, there's no errors, but you're going to get unexpected result. So right now, if I print out A, what is it going to get? Nothing, because you don't return. Although you can do the summation, but you didn't return the result, nothing is going back to the program. Use this. Make sure that if you want to return something, make sure you have the return keyword in there, so that when you recalculate and return, it's going to get you some result back. Make sense? So next, let me get you a little bit more complicated. So how about this? Will that work? Can I do that? Now the program failed. And this is where you can really use a function, right? Think about that. How do I handle this one? Right? How do I remember what we did earlier, right? Use a while loop. Can you do that in here? Where you can actually figure out. So you need to actually loops to the list. And then if that things cannot be converted to a number, then you're going to skip it. Right? Make sense? So right now, in the function, I can handle that. So what I'm going to do here, can think about, I can um, um, I can design a new value. I can maybe, how about, let's say final, okay, equal to a new list. What we're doing here would be for value in values, okay, and then within here, then you are using a try exceptions. You want to say try, and you can say final append in, okay. I'm going to use the float number, okay. So you want to turn this one to a floating number, and then going to append this one to the new list. And if this fine, you append it. If this otherwise, you can say pass. Pass means you're going to skip, that you don't do anything. So what this one is doing here, this simple improvement, that means, okay, we're going to loop through all the values and then convert it to float number. If it works fine, you want to append this one to the new list. Otherwise, you're going to skip. So after that, you want to calculate the sum of this final rather than the value. So now it should be this one, okay, final. Make sense? So now if I run this one, pay attention, right? It's work now. See? 26. Keep whatever you have, right? I can have another one here. And it doesn't matter, right? I can have another string. I can have another number. Okay. So also within here, you can also print it out, right? You say invalid value, something like that. So in here, I can add another one, say print, okay? Value is not a number, something like that. So now it's going to loop through the item. It's going to print out two lines saying that this one is invalid, this one is invalid. If it's a valid number, it doesn't do anything. So one is one, one is one. Okay? You still get the correct answer. But inside your loop, you can do something to exclude those invalid numbers. Make sense? So this is why it's so powerful, because right now, this same code block remains the same. All I need is just call this function. So I can do it again. I can call this one here, say some values. Okay, so now it doesn't matter what I provide. It can be A, 3, 5, 7, 8, blah, blah. Make sense? It works. And one step further, right? How about this? I just write 2. Will that work? What do you think? Will it work? Probably not, because it's not a list. Okay? It is not iterable. That means you need to provide a list. So you need at least something like this, square brackets. Thanks. Huh? But I want the user to be able to provide. I can even say, for example, here, 2, 3, 4. Right? I don't need to write the list. I would expect this one to work. Right? The user can provide list. But this is actually a tuple, not a list. So how can you handle a program to make sure that it's a list? And come here, finally we're going to blah, blah, blah. So here, this is where you can actually track the data type, okay? You can say, if not is instance list, right? So that means if the input is not a list, it's going to print out, okay, you must provide a list of numbers and then just return none. So that means it is not going to do anything. So in this way, rather than your program is running into like errors, it's actually print out a message. That means you already think about what situation it might occur. So you already handle that. So this is a better, right? So right now, if I run this one here, right, execute and run this one, it will be just fine. And even for this one, you see right earlier it was type error. Right now, what is this? Oh, okay, this one here, because we only have one argument. Okay, so right now if I run this one, see, it's not an error anymore. It's just print out a message to tell you that you must provide a list of numbers, something like that. Make sense? So if each instance is to track whether something is a certain type or not, right? I can also right now, this is not a list of numbers. I can also do, for example, if it is an integer or it is a float, I can turn that one into a list and do it like that. So it'll be like this. So one step follow, I can say if is instance and then values int. So if it is an integer, I'm going to turn the values into a list. Make sense? So now that means my program works for not just float. It can be integer. So in this case here, this one right now is work, okay? Because if there's a integer, it's going to turn it into the list with just one item. Okay. So it's up to you how you want to handle. You need to design. This is where the so-called algorithm design is. What you want to do, you need to take into different scenarios, and then you handle that within a program rather than just error. That's no good. So in this case, I'm going to show the message telling you, okay, I can also give it a little bit more explicit. I say if you enter a number, I can say print, and then tell you, you provided a number converted to a list. This can give the user a little bit more information. By this one, and then now if I want this one, okay, you're gonna have a line, and also this is not an error. Make sure you understand the logic, how you want to handle that, and arguments. You can have return values. We did talk about this one. You can make the arguments optional if you provide something equal to something. So it's up to you whether you want to have some, for example, right, first name, last name, middle name. If you don't provide, it's going to be empty. So you have equal sign to something. Again, you cannot have an equal sign at the beginning and then don't have equal sign after. So optional parameter need to be after. So these are called require parameters, require arguments. These are called optional arguments. That means you don't have to provide. And optional arguments follow require. You cannot have optional first and then require. Don't mess around the order. And in terms of return the result, you can return anything. You can return a number, you can return a list, you can return a value, you can return a string, you can return pretty much anything, any object is valid that you can return. So try to go through the numbers, go through the examples, and practice. You can pass in a list, you can pass in a number, you can pass in all kind of stuff. And so the function arguments can accept anything. So give me something, I give you something. And what you give me, it's up to you what you want to give me. It can be just one item, you can give me a block of items, you can give me a list, you can give me a dictionary, you can give me an object. It's unlimited. And I can give you something back, like it's also unlimited. Anyway, I think we are out of time, right? Okay, and that's all for today. I will see you on Friday. So make sure you practice, go through this whole list. We might cover a little bit more the last portion of this notebook on Friday. Okay.